You guys a video on how to predict products and then how to write the reactions and how to balance them. So that is what we are going to do. I'm going to do page 271, question number 33. A says zinc plus sulfur yields. Well, since I have two individual elements, that tells me that this is going to be a synthesis reaction. And so formula for zinc is Zn. Formula for sulfur is S8. Those two guys react together to form zinc sulfide, and to know the formula that this is going to be, let me get my different colors up here. Zinc, I know, is always a +2. Sulfur is always a -2. So when you put these guys together, they automatically balance out. So it's just Z and S. And to balance this reaction, we'll need 8 ZNSs and then 8 ZNs. I'm not going to worry too much about states here. Just worry about getting the correct product predicted and then the compounds written correctly and the equations written correctly. So B says calcium plus sodium nitrate. Calcium is Ca. Sodium nitrate. Sodium's a +1. Nitrate is a -1, so that's just NaNO3. Looking at this, I have an element plus a compound means that this is going to be a single replacement, and calcium will be a +2, sodium will be +1, nitrate is a -1, so that means calcium and sodium are who is going to be switching places. And when calcium takes the place of sodium, we now have calcium with a +2, nitrate with a -1 means that we need 2 nitrates to balance that out, and then plus the sodium all by its lonesome. I'm doing that again. Sorry. And so to balance this equation out, we have 1 calcium, 1 sodium, 1 sodium, 1 nitrate, 2 nitrate, which means we need to put a 2 here. Since we put a 2 there, that means we also have to put a 2 here. Alright, let's do, how about purple? That sounds good. C says silver nitrate and potassium iodide. Okay, first we got the formulas for these guys. Silver is Ag, nitrate is NO3, potassium is K, iodide I. Charges on these guys: silver's always a +1, nitrate's always a -1, potassium's always a +1, iodide is always a -1. So our actual formulas for our reactants is going to be AgNO3 plus Ki. I have a compound plus a compound means that this is a double replacement reaction, and I'm going to switch my cations, and since everything numerically has the same charge, I can just switch them. I don't have to worry about crisscrossing or any new subscripts or anything like that. So I just end up with KNO3 and silver iodide, which you guys will learn in the future. This is a precipitate. Let's do orange, why not? Okay, D says sodium iodide. And then it just gives us an arrow with a little heat symbol over it. That little heat symbol is a dead giveaway, but the fact that we only have one reactant is the biggest giveaway of all, that this is a decomposition reaction. So figure out our compound. Sodium is always a +1, so that's Na plus. Iodine is always a -1. So put those guys together and you get NaI. Yields. When these guys separate, you're going to have sodium and iodine. And remember, iodine is a Brinkelhoff, so it's I2, which means to balance this, you got to put 2 there and a 2 there. Okay, E gets into the kind of reaction that I didn't talk about in class today, and that is, they say, toluene plus oxygen yields. They were nice enough to give us the formula for toluene as C7H8. And of course, anytime you have pure oxygen, that's going to be O2. Now, this kind of reaction, anytime you have something reacting with oxygen, this is a combustion reaction. And the combustion of a hydrocarbon always produces carbon dioxide and water. So now all we have to do is balance it. And sometimes balancing these things can be a little bit of a pain, so it might take me a couple seconds. So let's see, we got 7 carbons. We have 1 carbon, so I'm going to put a 7 out here. Then I have 8 hydrogens. I have 2 hydrogens, so I'm going to put a 4 right there. And then I have 2 oxygens, and I have 7 times 2 is 14 oxygens, plus the 4 is 18. So this one wasn't too bad. Just throw a 9 out there, and we're balanced. Just to throw another couple of examples out there, let's say we're doing aluminum plus mercury acetate. This would be mercury 2 acetate. Anytime you have an element plus a compound, your like elements are going to swap places. Well, aluminum will form a +3 charge. Mercury in this case, according to this 2 right here, is a +2. And acetate is always a -1. So our positive guys are going to switch. And you're going to end up with, since aluminum is a +3 and acetate's a -1, you'll have aluminum acetate. 3 of them to balance out that charge, plus pure mercury. And then to balance this out, we got 1 aluminum, 1 mercury, 1 mercury, 2 acetates, 3 acetates. Least common multiple for 2 and 3 is going to be a 6. So what do you have to do to a 2 to get 6? Well, you got to multiply it by 3. What do you have to do to a 3 to get 6? You got to multiply it by 2, which means we now need to put a 2 in front of this aluminum and the 3 in front of this mercury. If you have any more questions about how to do these, just come on in the morning and I will help you out as best as I can. And no, there is not a pre-lab tonight because I was not able to get into the lab in order to get everything demonstrated for you guys. So the only homework you have to do tonight is that worksheet that I gave you to do again. So y'all have a great night and I'll see you first thing tomorrow.